Hello everyone, my name is Chantel, and for this Riviera-PRO video, I'm going to show all the tools that can be used for assertions debugging. Assertions are very useful in design verification because they can monitor the design behavior, check the function of interfaces and protocols, and can even be active documentation for what's going on in the code. Unfortunately, it can be a hassle to keep track of all the assertions and what they do when performing simulations, especially for large designs. But that's where Riviera-PRO comes in. Riviera-PRO has a number of debugging tools to help track and analyze all assertions in a design, like a window dedicated to listing all assertions, to coverage reporting for assertions. And I'll be showing all of it in this video. So let's get into it. For this demonstration, I'll be using a Riviera-PRO example design called Simple UART. The function of this design is as its name suggests. This can be found in Riviera-PRO's example directory by going to the assertion subcategory and then into the mix folder. This example design already includes a variety of runme macros, and I'll be using and editing the runme3 macro. Included in this are commands for setting working directory, sourcing procedures and variables, and creating a project library. In the compilation command lines, the debug parameter is passed. This is important because without it, none of the debugging windows will be usable during simulation. Then there's commands for starting simulation and adding the assertions and signals to the waveform viewer. And there's also a command for opening the assertion viewer window. After that, there's a run command followed by this assertion report command. Earlier I mentioned that you can generate reports for assertion coverage, and this is another form of a report for assertions. So this is how the macro is laid out by default, but I'm going to add a few more things to get more information out of the assertions. The first thing I'm going to do is add the argument plus trace assert into the asym command. This generates additional reports for assertions that will display the cause of an assertion to pass or fail inside the console. I'll also add the advanced dataflow argument because I'll be showing that you can view assertions in the dataflow window. Immediately after this line, I'm going to add a new command called assertion trace. And I'm just going to get tracing for assertion failures, so I'll just add on the arguments -fail followed by -enable. The next thing I'm going to add is the command to generate the ACDB coverage report for assertions. So I'm typing out ACDB report -cov a-html after the assertion trace line. And this will generate me an HTML formatted coverage report for only assertions. Now that I've added what I wanted, I'm going to execute the script all the way up to the line before running the simulation. And now before I run the simulation, I'm going to switch over to the debug perspective. And I'm going to talk about the debugging windows that can be used for assertions. The primary window for assertions is going to be the assertions viewer. This is where all the assertions of the simulated design are going to be listed. Then we have the waveform viewer, where you can also view all the assertions if you add them in here. The hierarchy window is also another window where you can view your assertions. Assertions will always be seen with an icon that looks like this, and you can find them inside of PSL units, where these units have a unique pink or blue block icon next to it. You can right-click on the assertions in the assertion window, and you can add them into the other debugging windows I just mentioned, plus the watch window and/or the advanced dataflow window. Adding an assertion to the watch window will display the current simulation time info for values, types, and last event times of the assertion and its associated signals. It's also possible to use the context menu of an assertion and set assertion breakpoints. These will occur for specific values, like if the assertion started, passed, or failed. I'll add a few of these breakpoints. I'll add a start value breakpoint for check reset, and a passed and failed breakpoint for check TI flag. I'm also going to add these two assertions to the advanced data flow window. And now with everything set up, I'm going to go ahead and run the simulation. As you can see, the simulation stopped at 10 picoseconds because a breakpoint was hit. Looks like the check TI flag breakpoint for the passed value triggered. This can be confirmed in the assertions viewer by the color of the icon next to the assertion. The status of the assertion affects the icon's color and symbols. The gray ones have not been activated as of yet, and the light blue shows that the assertion was just activated. These assertions can also have an expand button next to it, where expanding will display a list of the signals and clocks associated with the assertion. At the bottom of the assertions window, you can see the different types of statuses an assertion can have, such as failing and failing vacuously, along with the number of assertions that are of that status. Notice also that the evaluation path count, attempt count, and some of the other information columns, like the pass count and the last event time, have changed. These will update as the simulation goes along, and in this window, you can add even more information columns to look at, like the type of assertion and many other types of counts. I'll click on Run again, and I've reached the failed breakpoint for check TI flag. I'll run one more time, and now I've stopped at the passed breakpoint again. But notice that the check TI flag in the assertions, waveform, and hierarchy windows have a red assertion icon with an X, even though the assertion just passed. This is because assertions have a global and a local status. The global is the status of the assertion from the very beginning of simulation time all the way to the current simulation time, and is shown by the icon next to the assertion. The local status of the assertion is the status of the current simulation time that's seen in the value category in the debug windows, like the assertions viewer and the waveform viewer. If an assertion fails once at all during simulation time, the global status will mark it as failed, regardless if it passed at the current or previous simulation time. In the data flow window, the assertions are in blocks that are highlighted pink and outlined in blue. In this window, you can see how the assertions are getting their signal values, and you can see the values get updated in real simulation time. This is really helpful for viewing the connectivity of the whole design with the assertions. You can use the context menu of the assertions in this window to highlight them in the hierarchy or assertions windows. Now I'll move to the waveform viewer and zoom to fit. Notice that the waveform is pretty colorful, and that's because the waveform viewer shows when the assertion started and when their evaluations end, along with their status value. Similar to the global status icons, the greens indicate passing, while the reds indicate failing, and the yellow means they've been activated. The waveform viewer also combines all the iterations of an assertion into a composite and overall view. You can click on the expand button to show the evaluation of each individual iteration, like here for check send init, where one of the iterations failed, while overlapping the other iteration, where that one constantly activated and passed vacuously. I'm going to click on Run again, and as you may have already noticed, the console shows when an assertion fails. And recall that earlier I enabled assertion tracing to trace for failures. So not only do I get a console message for the failure, but I also get a message, thanks to enabling assertion tracing, that shows what caused the failure. you can double-click on the error or the trace message, and either one will open up the source code of the assertion. Now that I've covered all the debugging windows and tools for assertions, let's wrap it up with the reports. I'm going to disable the breakpoints, and I'm going to go back to the macro to run the rest of the simulation and get my reports. I'm going to go back to the default perspective, go to File System, and now the ACDB coverage and assertion reports are there. I'll first click on the AV3 report file, and what I get is a verbose report showing the name, hierarchy, assertion type, value, and all the rest of the assertion information for each assertion listed. Clicking on the ACDB coverage report HTML file opens up an all deck coverage report page. Since I only wanted assertion coverage, I got a report showing just that. The first page that pops up shows the cumulative summary of the number of assertions that passed out of the total assertions. The hierarchy page lets me expand downwards to see the assertion coverage information for each submodule. And each table shown shows the name of the assertion, its source, and the number of times it passed and failed throughout the entire recorded simulation time. And that's the end of this demonstration. Whatever it is you need for assertions, like monitoring all assertions during simulation, or generating reports for post-simulation analysis, Riviera-PRO has all the tools you need for a more robust and user-friendly debugging and verification experience with assertions. For reference on these tools, you can head to the user guide by going to Help, Product Help, User's Guide, and all things related to assertions and assertion debugging will be in this assertion section, with the assertion debugging located specifically in the subcategory of assertion support in GUI. Thank you for watching.